We can actually kind of go ahead and get started today. We're actually going to kick things off with an icebreaker, which was Julian's idea. Or Julian shared an article with me, which I figured we could kind of turn into an icebreaker. So yeah, we can start off with that, maybe spend the first 5 minutes or so on that as folks kind of filter in. But yeah, thanks everyone for coming. This is going to be the first computer science specific session of Flint. We're starting to branch out into doing some subject specific sessions because we mainly heard a lot of interesting ways that you all are using the platform and kind of want to create a space where folks can share with one another how you've been using it, and so that we can share a bit more kind of in-depth technical use cases of Flint, for different coding languages, for example. Quick itinerary in terms of what we'll cover. We'll do that quick icebreaker in a minute, and then we'll have like space just to kind of share with one another about how you all have been using Flint. There's a few of you here today that have also volunteered to kind of share about your experience. Julian, Matthew, I see both of you on the screen. I think there's a few other folks that I can't see on my laptop right now, so appreciate you all making it. And then also, you may have noticed that we launched a pretty big update to Flint yesterday. We're calling it Flint V5. And there are some computer science specific updates in there that we want to cover a bit more in depth, and eventually would love to hear y'all's thoughts on it once you have a chance to play around. This session will be recorded, and questions are welcome. Like at any point, you can keep it pretty interactive. Starting with that icebreaker, which again, credit goes to Julian for that. Starting off a bit on the extreme end, right, around like thinking about the future of what AI is going to bring for computer science education. Julian shared this article with me, basically highlighting how Salesforce will not be hiring software engineers this year, likely due to AI advancement and just like how much more productive their current software engineers already are with AI. So obviously, teaching computer science in middle and high school is a ways away from like students majoring in computer science and pursuing software development as a career path. But yeah, would love to just hear as an icebreaker what you all think the future of computer science education would be as the future of software development also changes. Yeah, no, Julian, if you wanted to start off, if you had any thoughts, or yeah, Wes, go for it. Yeah.
Make sure I'm not muted. Well, I mean, I think it's just going to radically change coding to the point where it just raises the bar so far in terms of what people can do, being able to articulate clearly with detailed prompts, and then using documentation and things like that as a library. My mind is blown, and it's such a struggle, thinking about what, how is this going to mean we teach differently? But I definitely think it means we're going to teach differently, and we need to be using these tools because they are being used in the workforce and they're going to be used there. So, there's a place for scripting, but I don't know that everyone's going to have to script in the same way that they have before. And yeah, that's a jumble of thoughts, but it's a definite game changer. And I know that I've experienced it already where I've created things I wouldn't have been able to create otherwise. So I think we want to elevate the bar of what students can create and what they can create sooner. But I think it's, challenging me to think differently about the kinds of things I'm requiring everybody to do. But I'm very much in a discombobulated, figured out.
That makes a lot of sense. Yeah, Julian. Yeah.
Hi everybody. I'm Julian Cochran. I teach at Durham Academy in Durham, North Carolina. One of the things that I really benefit from the area where we are located is we were in the research triangle in North Carolina, and the head of undergraduate computer science education at Duke, Owen Astrakan, both of his kids have gone to school here, and both of them took the old AP computer science A from me. So in the tenure I've been here, like this is my 26th year working at DA. Pascal, C++, Java, and now introduced Python probably in the last 10 to 12 years for intermediate, and now an advanced post-AP course. We've benefited from having that brain trust of undergraduate computer science education. Owen used to be a chief writer for the AP exam and all kinds of things. Like, what does Duke want to see with undergraduate computer science students? So it just went from like, hey, everybody learns Java, great, to now like, hey, if we have kids who come into our program that know 2 languages and they can see how to solve problems in all kinds of different ways. And I think if I'm not mistaken, Duke is using Python for their 100 level classes now. So using that benefit here in our area locally, and then the next step is another kid who was in my homeroom for the last 4 years. His dad's in the engineering department at Pratt at Duke, and I have former students that are coming over, and he keeps saying, like, what are you doing with these kids? Like, this is awesome. This kid already knows how to do blank. And hearing from those education side, but then also private sector parents, wow, this is how AI is changing our business, pharmaceutical research, tech. Parents got a big role at Cisco also and what they're doing. And so just, parents coming to encourage us to say, and we're in a relatively populated part of North Carolina. And I mean, we're independent pre-K to 12th grade school. We're competing against some flagship schools in North Carolina who are technology based, including the North Carolina School of Science and Math, which is a public residential 2-year school here in Durham. And so we're trying to, what is our niche at DA in terms of technology education? How are we leveraging use of an LLM to make sure that our students are graduating from high school? Are they ready to use that in the coding classroom too? And I don't know how many of you use the JetBrains products in your classes, but that's what we use for all of our coding development. And my students use GitHub as version control and everything like that. But if you're teaching using the JetBrains products, I could sit in class with most of my students, they could just hit the tab key and write most of the programs that we're writing right now. So, how do you still get a kid to understand the concepts of computer science when really all they have to do is start typing system dot, and then the program wants to complete the line of code for them. So that's how bringing Flint in and working with Sohan and his teams really helped me a ton, and just all kinds of different ways. And I'm going to shut up and let somebody else talk now. So.
I apologize, I forgot to say West Fryer Middle School Coding and Providence Day School in Charlotte, North Carolina. So just a little south of you, Julian.
Very good, Wes. Nice to meet you.
Hi, everybody. My name is Max Montgomery. I'm the head of the computer science department at Noble and Greenhouse School outside Boston. And Sohan and I spoke recently, and I asked him a similar question about the future of CS education. And I agree with him when he says that I think the typical software engineering job, as this our Salesforce article elucidates, is in its waning years probably. This is the idea of like picking up tickets and like basic whatever, like ticky-tacky early entry software engineering jobs. And I think that the availability of those jobs and how high paying they are and the economic kind of viability of a computer science major in college has really informed CS education in college and high school, where we've been really oriented towards building kind of like industry useful skills because they're directly applicable to the big tech coming right out of undergrad. And I think a lot of computer science education has been structured to meet that goal. And I think that it will be freed from kind of this idea that it should be an economically, like, the pedagogy should be building towards like directly applicable skills right away post finishing your education, which could be freeing, or at least make computer science education a bit more creative. So I think that there's still a huge importance to algorithmic thinking, computational thinking, kind of the primitives of what it means to be a programmer or a participant in technology generally, which I think can mean to more creative ways of teaching computer science, where it's not just like Java syntax and hammering that home. And I don't know what that looks like. But one of the things that really excites me about Flint is that it's a early new paradigm, new medium for learning and about computer science or anything really. And I think it's early days both for Flint, but also this sort of paradigm of learning what it means to code, for example. So I don't know where it's going, but it's going to be different for sure.
I'll jump in. Kelly, South Florida at Pinecrest School in Fort Lauderdale. I have this conversation a lot, and we've done a complete switch. It depends on the age of the child. I fully believe in the 6th graders learning the concepts, but by 8th graders, because I teach 6th grade, 7th grade, 8th grade Python. The 8th graders, by 8th grade, the kids are using a lot of AI, but the reading and the ability to solve problems has become main of our focus. And I don't know if you've heard of Brian Aachen. He's like a PyTest dude. He's like the PyTest, loves to yell about testing. And I think we had a great conversation about it, and the idea that you're gonna make first just like make it work, and then you're going to make it right. So the idea of being able to test the code, make sure it's functioning the way way you want to, is still going to be needed. So that ability to solve the problem and know where you're going, that's going to change. So I have a problem with Salesforce saying that they're not going to hire more software engineers. They're just going to hire different software engineers. Jensen Wang, I don't know, I'm sorry, I pronounced his name wrong. NVIDIA guy, he was saying last year, no one's going to need to code anymore. No, we're all over that, done. And then last week at his huge keynote speech, he was like, any developer who's not using AI is never going to make it at work. So he's totally switched the fact that we're still going to need coders, but we are definitely going to use the tools like Julian said, PyCharm. We got Colabs producing full code with us. We got Flint on the side, or AI, ChatGPT. So yeah, I don't believe no more software engineers. It's just going to be a new kind of software engineer. And so that's what we've shifted in our program. We've done a lot more of reading code. I always tell them, okay, I'm going to produce something with Flint. Here it is. Let's print it out and let's decipher it and tell me what it's going to do without an editor. And I think that's changing the way the kids are looking at code. They can't write code as well, but my students can read code really well.
Yeah, actually, I'm Jinseo, CTO of Flint, and I 100% agree with Kelly. So I really think that all the new software engineers are gonna be more like engineering manager going forward, and engineering manager at that point is gonna be called software engineer. So I think that's how it would be shifting. And I feel like good engineering manager, they used to be a really great software engineer, so they need to know how it works. So if you want to be a good software engineer from now on, they need to know how to code, see how the code works. It's similar to like these days, even though like I was a software engineer, like coding with JavaScript, I still need to learn how like memory allocation and releasing works, so that I know how to like not waste resources. And similar to that, it's like up from that concept, engineering manager definitely will need to know how coding works so that they can manage the AI software engineers better in a more efficient way. Yeah.
So this is Karen McKenzie. I'm at Carey Academy, just outside Raleigh, North Carolina. And it's one of the things that I think we talk the most about here is, it doesn't matter what language we're teaching or what syntax we're teaching. A loop is a loop is a loop. And that's really kind of where we are. And the goal for us at the end of our intro course is that, very similar to Kelly, I should be able to put any sort of code in front of you and you have a good idea of at least what it's going to do. One of the things that I do struggle with, and that we have a conversation here, it seems like all the time, is, okay, well, it's not about syntax, but we still have to start with the syntax. So which one? And we talk a lot about how the kids are coming in younger and younger with Python, all these things, and that's great. But when at some point somebody's going to need to know about data types and about memory allocation, and do we want to continue to have these students feel like, oh, they are these awesome coders and they can do all of these things, but they are missing some vital basics if they really want to become one of the people developing these things in the real world, not just the, oh, I'm going to be engineering and making changes and updates and things to design, but really be those who are behind the scenes in the true on design of these type of technologies. So that's just something we struggle with here a lot.
I'm actually hoping that like Flint can right now help teach like students learn how to like code, but maybe eventually they're gonna learn how to order to Flint to code for them, and then they can like help them iterate on top of that. That's what I'm hoping to see. Yeah, happening on Flint.
Sorry, jump back a bit. Talking back to Jinseo and the Flint, the thing that I'm sorry, I forgot who just spoke, but I want to reply back to. I agree with the foundations. For example, if you tell a student who's new to code to manipulate files and use AI to do it, if they're not able to read and decipher where it says insert your file here, and they don't know where the path is, or they don't know how to use the vocabulary word to get the path, they run into this infinite loop. You know, if you're using Jupyter Notebook, the AI in Jupyter Notebook will say, you know, if you click debug, it'll say insert your file and follow the path. Well, that's where a student goes into this loop of confusion. So having to teach some foundational knowledge so that the student can ask the appropriate question. You know, context, the more context you give an AI, the better the content that's produced. And if the student has no context of a data type or a file structure or a file path or a certain library, then they get stuck producing a code that might not do exactly what they want. So there is a fine line between a foundational knowledge and curiosity, and pointing them into the direction of where they need to go with the AI in order to produce the concept, the creative idea that they want.
Awesome. I know we have a couple hands raised, but I will kind of move on to the next section just in the interest of time. And then, of course, time permitting, we can come back to it. And then one final thing I wanted to add is, like, I know this headline is a bit doom and gloom, right? Which is good for getting the conversation started. But the reason why I think software engineering has historically been a very high-paid job is because it's very high leverage. One engineer can write a code, and that code can be, rolled out to millions of customers, right? So if Salesforce is saying, hey, our engineers are so much more productive that we don't need more engineers, that actually means that engineering is becoming even more high leverage. So I think that's going to result in there being even more startups, for example. And the average startup, and we're already starting to see this, is able to do a lot more with fewer engineers. So I think there's going to be more innovation as a result. So I think less people work at big companies like Salesforce, but I wouldn't be surprised if there's actually just more engineers in the future because of AI. Jumping to the next section, this is going to be a bit more kind of like group conversation. Would love for any of you all that have used Flint with your students to kind of share. So I'm going to pull up a few kind of guiding questions. As I pull each of these up, I'm just going to put them in the chat as well and stop the screen share so we can see a bit more of everyone's faces. So first question, I'm going to kind of put out there. I know there's a few folks on the call here that have volunteered to also share. And Julian, if you want to start off, feel free, because I know you're on a little bit more of a time crunch. What's an example of a Flint activity that you've tried with your CS students, and how did it go? And then over the course of these questions, we're going to drill down a bit more into specifics. So I'll put that question in the chat, and anyone's welcome to go ahead and answer.
I'm heavily rubric driven, and over teaching computer science for 25 plus years now. Karen, you may have joined late also, but I'm at Durham Academy, so nice to see a neighbor on the call here too. So a rubric in pre-Flint was, this benchmark, this benchmark, this benchmark, meet all the benchmarks, get the points out of them, bam, there's your grade for the lab. And we all teach high school students, and we've all been there with computer science, where you're like grading a program and you're like, did you not even read the rubric that I sent for you to work on this program? And something that's really changed now that I've specifically, okay, so what like a specific thing that I've used Flint for, Java collections framework deep dive. Set up a tutor to work with a kid for a 30-minute session to talk about, like, okay, what is Java collections framework, and why can't the Java collections framework store primitives? Why do you have to have objects? What's a wrapper class? All those are kind of other good things. But then the other thing I've really started to do is I'm changing my rubrics now to where, a 100-point lab or project, instead of having 100 points worth of simple benchmarks and bullet points, now I'm dropping that down to 80 points. And the final category, which is a 20-point category, is create a tutorial session on Flint in our class, and have a class that I've set up for all my courses, and my kids can create their own tutorial sessions, and use Flint for project ideation to add some sort of extra to this project. recent lab I did in my AP Computer Science A equivalent was a base converter program. Open a file. It's got a flat file database, number, tab, delimited text, what base it's in, tab, delimited text, what base you need to translate it to. So the kids were ranging from bases 2 to 16. How can you flag invalid bases, like any base that's outside of that value? That's pretty simple. But then I said, okay, so you have to use Flint to project ideate and figure out what would be a really cool extra. And I had kids come back with like, wow, I figured out if you gave me a base 12 number, like I used Flint to figure out how you could parse that number, and you can have like the digits D, E, and F in that number. And I was like, wow, that's a great extra. And the kid said, yeah, I never would have thought of that if I hadn't been able to use Flint. So that's a really super concrete way. And I'll also say that the flip side is that in some of my post AP classes that I'm teaching now, I'm requiring students to record a screencast video of themselves explaining their algorithm that they use, because we're pretty heavily relying on Flint. Like I've got a machine learning and AI class, and I don't teach it. I'm just a facilitator. There are 4 projects in the semester. The kids come in, it's their ideas. We start with a basic machine learning project. You know, we do like an A-star algorithm. Kids learn the Pygame library and like build an A-star program using Pygame, or they create, you know, the classic like snake game that trades itself as it goes. And so I'm having kids now record videos. So at that point, if you go to Flint and you're just like, hey, Flint, write all the code for me, awesome. You know, you can LLM prompt enough. If you know how to do that well enough, you can get, even Flint just put some stuff out that's serious nuts and bolts, so the kid doesn't have to know. But if they go to record that 5-minute video and they hand that link to me and they have no clue how to explain that algorithm, I'm like, okay, we need to revisit your use of AI. So those are 2 really concrete examples, and I'll pass it on to anybody else.
I'll jump in. I'm Matthew Davis. I teach at Episcopal Academy outside of Philadelphia. And I have a use case, but I want to talk a little bit about what Julian did. So at our school, we're really worried about AI usage and making sure that kids are using it to enhance their learning rather than do the work for them. So we've really taken efforts to be clear with the kids when they can use AI and when they can't use AI. So we have assignments where I'm like, you are not allowed to use AI on this. And there are other assignments where I'm like, I want you to use AI to try to create something better. So that's been really cool in Flint. Like, okay, if we're going to make like in our APCSA class, if we're going to make like a Space Invaders project, like maybe they can use Flint to come up with like really cool ideas. And like, I want you to create a real world product, like make something that's at a really high level. But then there are other times where I'm like, I want to see what you can do right here, right now. So it's also led to a lot more like stuff in the classroom where I'm not allowing them to take it home or do things outside of the class, just to make sure, you know, that we can monitor who's doing what in the classroom. I also teach cybersecurity. And so one thing that I've really found success with from the kids is having the kids have debates with the AI. So we talk a lot about Edward Snowden, whether or not he was a traitor or a whistleblower, and do a lot of ethical debates. And it's been fun to kind of prompt them and get them thinking one idea. So like we could spend some time in class and talk about how like Edward Snowden is like a whistleblower and he was great. And then I had Flint, I gave it the NSA and FBI documents that kind of talk about how he was a traitor. And so I told Flint, its job was to convince the kids of something. And they then like got into a big argument with Flint, like, no, he was a whistleblower. And they really liked that idea of like, they're trying to convince Flint of something and Flint's trying to convince them of something. So there are ways to use it in coding, but there are also ways to use it in some of the more like I don't know, humanities impacts or, you know, disciplines in computer science.
Yeah, that's a really awesome use case, Matthew, and it kind of ties into the next question I had, which I'm going to put into the chat now. So if you want to answer this one, feel free, which is, how did you introduce Flint to your students, and did it replace a pre-existing part of your lesson? So when I hear that like role play kind of debate style activity, out of curiosity, that's something new that you started doing because Flint and like AI models exist, or did you have like a different kind of way of doing an activity like that for those cybersecurity students in the past?
Yeah, before I had Flint, I like tried to have them read the FBI like write up on Snowden, but I mean, I don't know what your students are like, but they don't like reading anything that's more than like a page. And so like it just wasn't a great activity. And so just like trying to find ways to engage them. And like I'll say like I've had good days on Flint and bad days on Flint where I'm just like, Flint, do what I want you to do. But like I think in this specific activity, like if you're going to do something like it, I found it was important to have Flint keep it short because AI has a tendency to like give them walls of text, and so it was like really important to like engage your kids where they're at. And so like this is something that I had never really done a formal debate. Like it's not really in my wheelhouse as a teacher to like have half the kids research one thing and half the kids do something else. And I didn't have time in the curriculum to do that. But Flint allowed me to do that like really quickly and add this new thing. And we actually do it with a bunch of different like ethical debates. We use Flint to kind of like go back and forth, and then we'll come back as a class and discuss it. But just like kind of get ideas or like initial research. Sometimes I'll use Flint to have them use that.
Yeah, that's really awesome to hear. And as a company, those are kind of the use cases that we transparently are trying to promote more, trying to like embrace more, because when it's net new, the concerns even around like cheating, let's say, are less severe because it's a new kind of format and maybe there's some new learning experience you can have there. Yeah, Tim, would love to hear your thoughts as well. Go for it.
I think one of the things that Flint allowed me to do, and I just started it this semester, and I teach both AP courses, teach a class in AI, cybersecurity. Woodward Academy from Atlanta, Georgia, is when you go through and create your activity, and it will do a coding challenge, or it will do a rapid fire, or it will do a deep dive. I set up all three and was able to tell my students, I don't know how best you learn. You know that best. And maybe some of you are really good at the concepts and the coding, and you just want test prep because we're all playing the AP game. But some of you, it's more interactive and you learn very best by hands-on labs. And I can only give you so many, but Flint can give you a million. And so what I told them was, this allows me to give them self-directed study versus the old school. I mean, you can come to tutorial and I'll answer some questions, but if I have 7 of you from 3 different classes, like we'll do the best we can in our 35 minutes. Or you figure out what you need tonight to get ready for our test on arrays. And what I like is going through Flint now, different than AP Classroom. I can see the questions that they asked. I can see how much time they spent, but I can also get a better idea of the questions that they were asking Flint. I am tucking away of, this is what I need to hit next year, or this is discussed before we do array lists.
So I teach advanced topics with my kids. These are the kids who've already done the AP exam, and really kind of like Julian said, I'm more of the moderator and guide rather than teacher of any of it. But one of the things that we do in the class that I'm still in the process of trying to use Flint for is very similar to what Matthew was saying of, here's an ethical debate, or here is a, like the news article about Salesforce, that's going to be a topic of conversation in my class coming up. And typically what we'll do is have an online discussion where the kids are in response to each other. And so I'm still trying to figure out the best way to do that within Flint so they don't feel like they're just getting that one-to-one interaction. It's kind of more the group. But one of the things that I do have them do is they can change their project at any point in time. It's essentially like a glorified independent. They decide what they want to learn and they pitch ideas. And I'm having Flint almost act as a financial backer, if you will, asking the questions of, okay, well, what is this project? What is it going to be doing? What resources, like how can I help? Or, those type of things. Because what I'm finding is that, the kids have this great idea and they want to do something, but they don't necessarily, while they might be good at breaking down code in algorithm design form, they don't really see how to do it yet in a project or understanding why. And so Flint's really been good at helping them kind of think through breaking down those bigger project problems to get to where they want to be, rather than just, oh, help me with this line of code or help me over here. So something different.
That's awesome to hear. And kind of like a follow-up question for both you and Karen, Karen and Tim. I think one topic that you both are getting into is like new ways that students can use AI, either as part of brainstorming process or even like self-directed for their own learning. The next question I had is, have your students used Flint or other tools independently? So I'm starting to hear some source of that, but it's no secret that students have access to Flint on their own, and especially dozens of other AI tools out there. How has that changed how you're teaching? And are there other unique ways that students have used these AI tools to either brainstorm or understand difficult topics independently, even if it's not like a teacher directed activity?
I'm constantly surprised at how much more the kids independently are going to Flint for different areas of study. We did a pilot test of it at the end of last year. We really started it this year. By the end of the first semester, all of my teachers have found some sort of value, and even those teachers who are kind of on the fence. And I think part of it is because some of the students on their own are going to Flint and creating activities or using it as writing help or whatnot, that they're bringing it up to the teachers of, oh, can we use Flint for this? Or, oh, what if I could, try to do, or, hey, I was studying and this is how I did it. So I'm actually, when I go in and look at the analytics, I'm always pleasantly surprised to see how many activities are created by students versus by the teachers. And our teacher numbers are going way up as well. But it was always, like here, definitely student driven more than anything else.
Yeah, I would say on my end, it's the opposite. I am finding my students, I can just tell, they will use ChatGPT to find the answer. They will not use Flint unless I give them a lot of prodding to learn. Like, I walked through an example with the latest unit, and I tried to show them, in real time, when since Flint had the entire AP curriculum, for example, was asking questions about 2D arrays or solving something with the hash map, something they hadn't seen before. I showed them how you can correct it and say, oh, I haven't covered that yet, and how the question would modify all those tools. And they are very resistant, at least the students that I am interfacing with, to use it to learn versus tell me the answer. And so it is just a process. But I think incorporating the idea from before of using it to debate in my AI class, which basically every day is a debate, may give them more of it's not an answer key, it is a way to actively engage.
It's a good point.
Karen,
There's no right answer to debate. So yeah, go for Julian.
Sorry, Stefan. Karen, I had raised my hand. I was curious. I'm a computer science teacher, primarily a DA, but also, I'm the technology coordinator in the high school. So, hey, Flint, we're going to contract with Flint. Teachers, come to me. Let's learn how to use Flint. So that's my question for you. Like at Cary Academy, have you all had kind of a systematic rollout with all of your faculty? Is everyone coming to you for help? One of the things I love about Flint is kind of that Uber admin status that I can have, and I can go in and I'm just like you. I log in every day and I see all the updates of all the tutors that students are creating for their classes. I'm curious if you're communicating with your colleagues like, hey, did you know that 17 kids created a Spanish tutor for your quiz that you have coming up on Thursday, that kind of thing? Are your faculty learning about Flint because it's coming from underneath them, or are they specifically top down? They implement something in Flint in their classes, and then their kids are pushing it out and creating sessions. I was just curious what you're seeing at Erie Academy.
Yeah, so one of the things that we did was we were very intentional on how we wanted to roll out Flint. In the very beginning, you know, we had Sohan doing a demo with our department chairs, and it was just the upper school department chairs because we didn't want, middle school was going through renovation. We're like, we're not putting anything else on their plate right now. And so even within that department chair meeting, you know, we left saying that this is not a requirement. This is something we're looking at. And of all the different AI tools that are coming out, this is the only one that we're finding from a pedagogical standpoint, any course, any class or discipline can really find use for. And some department chairs were like, yep, this is great. They showed their departments. And then it was just kind of a little grassroots on my part of, these are my tech superstars, my teachers who come and show me all the cool stuff they find every now and then. And I showed them. And then from there, it kind of just spread. The only formal thing that we did after that was towards the end of the year, beginning of this year, we had kind of a show and tell and talking about AI in general. And instead of it being, okay, we're not debating AI. We're going to go in with the assumption that it's here, deal with it. But more, it was, we want those key people in our faculty and staff to share out some examples that they're doing. And it wasn't a show and tell per se of, let me show you Flint and how this is doing. It's more of what we're doing here, just talking about, you know, and coming up with ideas from each other. And the more that, you know, a teacher in this department would do something, those kids in that class that had that experience would then use it for something else in another department, and teachers would, oh, I heard about this, and what do you do? And then it just, you know, snowballed from there. It wasn't until the beginning of this year that my middle school teachers were actually upset that we didn't bring it to them last year. And they very quickly, my middle school science teachers, it's almost a daily event of them using Flint for something. And so it just, you know, some departments more than others. I'm so glad. I was at a department chair meeting the other day, and for the first time, my upper school English department is really using it. And I was like, wow, that was the department I was so least thinking because of academic integrity and those type of things, but they're using it a lot. So it was definitely a little mixture of both. I can't speak for DA. I know that CA, as soon as you tell our teachers you have to, it's no, done. It's more of, you know, kind of with honey and sugar. Oh, look at this. I did this, and here's how I, you know, saved my time on this and that. So.
We had a former upper school director describe Durham Academy as the most fiercely independent school. And I'm going to send my academic leader for English over to Erie Academy sometime next week to visit you. So
definitely, Armand has been doing. They're doing a lot with it, which again, I have to touch base with him because I'm still in shock and awe about. Wow, you guys were the least group that I thought would be the first in there, and there he is. So they're using it.
I just have a quick comment back to Tim. I can very much relate to kids just trying to use AI to do the work for them. One thing I do to kind of trick my kids is I make AI tutors, and I tell them that I gave it the test and that they should use it to study. And they're like, oh, maybe I can trick it into giving me the test questions. And even if I didn't actually give it the test and I just told it the topics, like sometimes I just straight up lie to them because like, why do they need to know what's in the back end? But like sometimes that subtle like social manipulation has been pretty helpful when kids are like trying to only care about grades.
That's pretty brilliant. You could even like create like a study guide AI activity. Be like, yeah, like this one has a better version of the study guide, you know. Like, yeah, you can use a regular study guide, but you might as well just use the one that's like a bit better, maybe has more answers or something.
Yeah, exactly. Like, I mean, they're idiots. They're kids. Like, they don't know anything. Like,
That's an awesome idea.
Yeah, just to follow up on that, I think what that helps also is it's a learning shift. So if my students are only interested in that, and that's the only thing their parents are interested in, what Flint also allows me is more data. And so then I can also say, I have provided them those 3 tutors. I told them the test is in the tutor. They did not log in. Like, this isn't a learning, like, this is a behavior issue. I mean, it's all the things we've faced in education for years. But I do like having more options for them remotely at any time, the way that they like to engage.
Awesome. With that, I'm going to jump into the next section of things. Awesome discussion, though, and feel free to keep it going in the chat if you want to continue kind of putting open questions out there for folks to answer. What I'll be sharing now is some of the updates we've come out with as part of this V5 update that are more relevant to computer science specifically. And if you're curious in learning like what's new in V5, I'm going to go ahead and screen share this page as well, which includes like, quick demo video of the changes as well as like, specific details on what's changed. And we will also be having a campfire session about these updates in a couple of weeks, or actually I think next week. So I'll put the chat in here. I'll put in the chat here the link to this what's new page in case any of you want to check it out kind of on your own time. But specifically for computer science, we actually do have a few updates in store that weren't covered in this doc. So I wanted to kind of highlight those for you all. And of course, we'd love if you have a chance to try it out at any point and share your feedback. So one of the biggest things is that we've now added a coding challenge shortcut to Flint. And you'll notice that the general process for making an activity in Flint is hopefully a lot more seamless and conversational than before. You can still do prompt engineering, so if you have your own prompts to use, you can definitely use those. But we made it easier to get started if you're using AI for the first time or something like that. Yeah, Matthew, go for it.
can you just full screen real quick? Sorry.
Oh, yeah, for sure. Actually, I'm going to switch slides in a second anyways. So
Okay.
yeah, this slide, yeah, feel free. If you can't read the text here, that's totally fine. I'm just going to put up on a big screen in a second. Yeah, so this is what Flint looks like now. Off the bat, it doesn't look crazy different, although we do now have this coding challenge activity shortcut. So if you have a chance, again, would highly recommend trying it out. Once you click that, instead of getting a pop-up with questions to answer, you're actually going to be put in a conversation with Flint. So we pre-fill this first message based on what you clicked. So here it says, hey Flint, can you help me create a coding challenge? And Flint will actually work with you to create this coding challenge for you. So you can basically type in your response to these questions or dictate it. So if I say something like, I'm teaching my students Python, they're intermediate learners, let's say at 10th grade, and I want them to focus on debugging if-else statements. You can basically tell Flint whatever you like in natural language. Of course, like before, you have the ability to upload specific content, maybe even attach a code snippet that you want the AI to use. But in this case, if I just answer those questions pretty casually, it will actually go through and set up this activity for me. So what it's doing here is just creating all the activity details, making those changes, and in a second, I'm going to actually be able to preview it here on the right-hand side. So all the settings we used to have before are still available under this build manually, this setting, but we basically have this like chat-like experience. If you've used OpenAI's GPT builder, it's similar to that. That will basically set everything up for you. So now, like before, if I want to preview like an excellent session, I can click play, and Flint will actually go through and show me an example of where a student does a really good job identifying the bugs. And then like before, if you want to make any changes to this activity, you can do that by changing the settings manually yourself, or you could just ask Flint to make a change. So if I say something like, just kidding, I want to make this a Java activity, it's going to be able to go ahead and edit the coding language, edit the code snippets that it provides to students automatically to now be in Java instead of Python. Any questions so far about how like that setup experience is different? Cool. So yeah, like before, you can use this really for any style of activity. Even kind of going back to your example, Matthew, of like the role play or like debating, whether or not Edward Snowden was a hacker or a leaker or something like that. You can basically give Flint objectives like that as well in the chat, and it'll be able to create like the corresponding activity. And then whenever you're happy with the activity, like before, you can click create, and nothing here has changed. You basically have a link you can send out to your students. We've also addressed a major complaint that we've heard from many of you around how the code editor works in Flint. So you might remember that before, when you try to edit code in Flint, it brings up like a pop-up which like covers everything you're seeing on the screen. So if you're trying to look at the chat window and like write code at the same time, it's like really frustrating for students. We have finally gotten around to fixing that and making it a lot more seamless experience. So now as a student, if I click start session, this is what the screen will look like. And I'll make this a little bit bigger on my laptop so that you all can see. As you can see, they can see the basic information about this activity like before. And they have this initial message from the AI. In this case, it's saying, hey, there's 2 bugs in the code. Can you go ahead and fix the bugs or let me know what the issues are? But students can actually open up this code and it's going to pull it up in this editor on the right-hand side. And this is all customizable. So if they go ahead and change this, let's say I'm going to go ahead and make a kind of nonsensical change because I haven't actually read this code myself and say something like, I fixed it. I can basically send that code back to the AI. It's then going to be able to read that, understand what I did differently, and give me some feedback. And then if I say something like, can you give me a hint via commenting on the code? This is maybe not something a student would realistically say, but just to kind of illustrate the point, the AI can actually edit the code that the student's providing to then provide hints and further guidance. So it's almost like, on the shoulder of the student in their editor with them. In this case, as you can see, it's gone ahead and added some comments, giving me some hints of how I can get started, and then I can continue editing this code and send it back to the AI. So with this change, we hope that's going to be a lot easier for students to like work back and forth with the AI on their code. And they can also download this code onto their computer or copy paste it if they want to like pull it in from like a different platform or export it out to their actual IDE to run it. Yeah, Matthew, go for it.
Does it have the ability to handle more than one file at a time, or is it just single file programs?
Yeah, it's just single files. Like you can't have multiple files kind of in the same directory. That said, you could have multiple files going on in the chat technically. So basically each of these like coding attachments, or we call them internally, are versioned. So of debug challenge.java, this is version number 1. Then there's version number 2, 3, and 4. But you could create another separate attachment. So let's say the student's now working on a different problem or they want to bring in a different code file. They could start a coding attachment from scratch. They can name this like, a test.java, for example, and then they can start typing it here. And now you'll see that in this conversation, you can go back and see this as a teacher. There's 2 different files. There's debug challenge.java, and then there's this separate file the student started. In this case, it looks like I didn't save the name, but it might be called like test.java. That said, you can't like open up multiple files at the same time, and they're not really the same. Like there's no like file structure or directory. But yeah, Jinso can share more.
Yeah. Also, you can now actually upload the code file, and then they'll be able to open up in that coding IDE panel to continue editing there.
I'm sure, like when I mess around with it, I'll find out. But like, let's say you had like just an object and a driver, and you were just, or like a runner, and you were just trying to like make instances of that object. Is it going to be good enough to know like that those 2 programs are related to one another, you think?
Yeah, I think it will do a pretty good job.
Great, thank you.
Yeah, something that's pretty cool as well is that the AI can simulate and run the code. So I've tried this out at least in Python activities, and it will actually go ahead and pause for a second, say, let me use a calculator, because it uses a Python interpreter in the backend to basically run code and compile it, and it can let you know as a student like what the results would be. So yeah, that's basically what these activities look like. And then like I mentioned earlier as a teacher, this is what you'd see when you pull up the student session. You can basically click through to see exactly what code they wrote and how that changed over time as well. So, yeah. Awesome. And yeah, any other questions about these updates? Cool. In that case, that's pretty much it in terms of the main content that we had to share for the session. So I have a couple slides to wrap up, and then if anyone wants to stay over to ask our team questions or to ask each other questions, more than welcome to do that till the top of the hour. We do have a few more upcoming Campfire sessions over the next couple weeks. So we have 2 tomorrow in case there's anyone joining from the other side of the world, from Asia. We do have a kind of session in the evening next week, specifically in a more favorable time zone for them. Later next week, next Thursday, we have a overview of all the different updates as part of V5. There's a couple more teacher-facing updates that we didn't get a chance to cover in this meeting. So in case you want to come by for that session next week on Thursday, that'd be great. I think it's going to be at the same time as this session. If not, feel free to share with other teachers that might be interested. And then the following week on Wednesday, we're going to actually touch up on the topic that came up earlier today, just coincidentally, around how students have been using Flint to self-study. So we're going to be covering some, interesting ways that we've seen students being using the platform, ways that teachers have been encouraging students to use Flint for self-study, and we'll have some teachers and administrators there kind of firsthand to present what they've seen happen at their schools. So as always, you can use this QR code link to register for future sessions. And yeah, that's pretty much it from our team. So thank you so much for making it to the session, and we hope to see you at a future one.
Thanks so much.
Of course. Thanks everyone for making it, and especially everyone for contributing and sharing how you've been using Flint and answering so many of the questions. Yeah, Tony, go for it.
You're muted.
Oh, yeah, Tony, not sure if you're still on or if you're talking or not, but I think.
Sorry. Yeah, I'm just curious if I'm the director of technology. I'm not the computer science teacher, but I do have a brilliant computer science teacher who he's not. He kind of struggles with AI. He doesn't really trust it, and I'm trying to get him to come around. And I was wondering if anybody had any sort of insight into convincing people that are already brilliant in computer science to get it to use or to even try it with their students. He's writing a book and he's using ChatGPT, which is driving me crazy. And I mentored his class recently for test prep. So I uploaded APs to a tutor, and the kids were doing test prep AP computer science questions while he was out. But now he's back, and they're doing projects that he designs. But I would really love to try to convince him to maybe use this tool a little bit more in his his daily experience. Any recommendations? He's also really high on the spectrum. So I thought this would be perfect for him, but he hasn't really bought in yet.
Yeah, she put it at 500. That's what she did.
Anthony, what I've kind of done as the technology director in the high school, but also teaching computer science, is just kind of slowly but surely going. I mean, at the departmental level, I'm going to departments and saying, "Hey, here's a demo. Can I help you design an assignment?" And I wonder if maybe you've already tried to do this, but just sit down with that colleague and say, "Hey, let's pull up one of your assignments that you have for your class. What's your favorite assignment that you teach?" And half an hour of playing with that favorite assignment and seeing, like, can we pull it into Flint and see how Flint wants to change it or can improve it or just make it different from what it is. What are the advantages of that? What are the disadvantages of that? I think for a lot of us as teachers, like a lot of what AI is doing, I mean, I started out using GPT and OpenAI stuff, and when we started working with Flint, I just realized I could start making tutors in Flint that help me write my interim comments, mid-semester comments that I have to write at the end of the first quarter and the third quarter, which for 70 students, it takes a long time to do this. Now, I'm not having Flint write them for me completely, but I'm sketching out a general diagram, quick 5 thoughts, plug it into Flint. Flint rewrites it using teacher speak, that kind of thing. So I mean, it's like for me personally, all of a sudden there's just this tiny little time-saving thing. In the computer science realm, I'm using it to design rubrics, and I post those rubrics for my students, and then they're able to almost sort of self-assess. And I don't know if you were here when I mentioned I'm having my comp sci students make videos explaining their algorithms of the code that they're writing and what they're handing in and where they got it. And Flint helps me with this, but then I found this really cool idea and blah, 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 blah. So it's becoming, so it's taking away some time that it's required for me to grade. I took I used to use the Littmans, Maria and Gary Littman publish textbooks for AP Computer Science, and I took all their homework exercises and made them Google Forms. And that was great because then there was some automation, but then I got to go grade all the Google Forms for like the free response questions. So now I've started taking those Google Forms and putting them into Flint and being like, I want a 45-minute interaction with Flint. Here are all the questions. Here are the points I want to assign for all the questions. Go give me a grade. And, it's saving me a ton of time as a teacher. It's just kind of a little bit of automation in my workflow. Yeah, it's a little scary to think like, here's this lab that I designed that I've been teaching computer science for 25 years, and I love this lab and I own it and it's great and my students will get so much from it, and I'm just going to hand it off to an AI and let an AI take care of it. But I mean, I'm starting to see the benefits of it, which is the time that I'm saving on the other end. I'll selfishly own up to the fact that, I love teaching, mentoring, connecting, getting kids to be curious, empowering them to problem solve. Absolutely hate grading. It's just like the slowest and most taxing part of my job, where like, the end of the week, I'm just like, it's going to take me 2 hours to grade all these labs, and to have Flint be able to come in and sort of take away that drudgery of that part of teaching that I'm not wild about. It's been kind of fun. I'm online at Durham. It's just julian.cochran@va for durhamacademy.org. You feel free to shoot me an email if you want some more ideas. I'd be happy to help you with advocating with that teacher too.
Thank you, appreciate it. But maybe I'll just show them this video. Thanks a lot.
That too, yeah.
Tony, I'll add some stuff if you're interested too. I mean, it's hard. I teach computer science. It's one of those things that's always been passionate for me. But at the same time, you have such a variety of kids in computer science, and we tend to teach for the great kids. The kids. These kids are going to go to computer science, but there's so many kids that could do computer science and will find places in computer science in their life, and this is a great tool, not for the great kids. I mean, sometimes for the great kids, but I mean, for helping those kids get the one-up step. I mean, I use Copilot, which is like another thing through GitHub with my students. It's also a good tool, but I can't see what they're doing with GitHub as much as I can see here. And Copilot is a great tool for when they're in the editor and they're coding and they need some suggestions and things like that, and also like fine-tuning things, and that's what they'll be using in the future. But not even future. Like I have students who graduated before, and they're all telling me like they're using various versions of AI assistants. But what's nice about this is like you can create an activity for kids that is tiered, like multi-level. Like I have a lot of like there's endless computer programs exercises that you can go, and they're self-solving, they're self-marking, they're self-solution, but they don't give any feedback to the kids. And this you could build in like those questions, and then when the kids get stuck, as opposed to saying like I'm just going to kind of drill, or I'm going to call my friend, or I'm going to do whatever, they can kind of ask the AI for help. And for those kids first starting out, they may give them a lot of the answer, but that's building the confidence, etc., to move them forward, and then they can build that piece. It's not a question of like we live in an age right now where any kid that I could give you any computer science test, and that kid can take it home and find some place to get all the answers. That's a given. So we shouldn't even think like, if they're going to use AI, they're going to learn the answers. They already can. Like that's the thing. But with a tool like this, you can see the conversation, you can see the dialogue, you can see like these kids are slowly starting to get it through the information that you get in there. And like I've only used this like 5 or 6 times, and I've used, believe me, like a dozen other AI tools, and some of them I still use in different ways. But I mean, like this, what I like about it is you see the conversation, and that's something you're not going to get in so many other ways. And the only way we get in the old school way is you sit down there with the kid and you have the conversation. But we know that there's only so many conversations you can have. So, and you can also look through the conversations that you have, and you can begin to pull out some ideas, some data of like what things kids are going to understand, what things, like that a third of your kids don't understand. So again, you're not teaching just for the smart kids. You're not hoping the smart kids are just going to tutor the other kids and come down, because that's pretty much, I've been teaching computer science for a really long time. I mean, I think I met you back when I was teaching in New York. But we need to help the middle kids and the struggling kids. I mean, the most struggling kids, those are the kids you're going to be talking to the whole time. But the kids that are just above those and just below, like the kids who just get it right away, you need something like this to have those conversations, to tutor. I mean, this is a decent tutor. It's not perfect. It's coming along. It's come a long way, and it's never going to be perfect, but it's been really useful in that way. It's also useful for like thinking about, as a lot of people are saying, like time-saving things of coming up with ideas, trying things out. And in a lot of cases in the past, when I came up with an idea, I had to do so much setup and whatever in order to get it done. Here, it's there's templates, you set it up. I'm going to try this particular set of problems with the kids and see how they go. And they've gone so far. I mean, I've had like 3 good ones, maybe 1 mediocre one, and a couple misses. But it happens. Just I would say to the teacher, if they're skeptical, it's just like, this is a way to have conversations with your kids. It's also a way for your kids to have a reliable tutor that you can kind of know when they're asking stuff. You can see how long they stay. Like I have one thing where I basically just watch how long they stay in it's kind of a drill and kill exercise. They're gonna like keep doing questions about loops, etc., or whatever, and I see like how long have they stayed. And some of the kids, like they come to me and they say, like, I really don't understand, like, how long you stayed in my tutorial to go through this and see. And then I have one girl who stayed in like 40 minutes, and that cured her of her fear of loops. I mean, so it's like, those are kind of stuff. I hope that's helpful to you.
Definitely. Thank you, Tim.
Yeah, and awesome to hear that you guys both already know each other. I had no idea. So
Yeah. I knew Tim a long time ago when he was in New York.
No way. Yeah.
How's Canada treating you?
It's cold. I'm telling you right now, it's cold.
You exported the cold to New York, my friend. It's freezing down.
Oh yeah.
Too.
But we're living in a democracy for now.
At least, yeah.
I want to get into there.
Yeah. Thank you again.
So
I just wanted to let you know, I've been playing around with the new analytics functionality, which is just awesome. And I think one of the best things about it was, and I didn't think to bring it up during this call, was me just asking Flint in the analytics section of what department has the highest usage of Flint. And it did a whole analytics piece for me, not only saying, oh, here's the departments that are using, but giving me examples of each of the departments. And I know that some people are gone already, but the first one, top number 1 right now, is English and literature, working on thesis development and thesis analysis. So it's been just that little piece has been such a game changer for me in being able to talk with my teachers and talk about, what they're using and what is changing. So kudos.
That's awesome to hear. And yeah, I'm glad that Jinso's on the call for this as well, because all credit to him for building and putting that together. So glad to hear that's been useful.
Thank you. So, because it's definitely such a huge bit for us, especially when we're talking about ROI, but also talking with our teachers. Look, I can pull this up and say, here's some other examples, because you might not talk to the math teacher or this, and being able to show that as exemplars, which is just great. So
that's awesome. Yeah, no, thank you for trying it already. I'm surprised it's only been out for like a day or something. So that's great.
And you know that we are touching everything that comes out. Carrie had me. We are always pressing a button. Oh, look, that's new. So, but yeah, no, definitely looking good so far.
Awesome. Yeah. Thank you everyone for making it. Staying over, answering questions, sharing all this feedback. I'm sure we'll see you all around. So yeah, have a great rest of your week.
Sure.
I,
I just have one quick question. Is there like a place where you're posting the videos of the piece, or yeah, okay.
Yeah, there's this page. I'll go ahead and put it in.
So I missed the first.
Of these sessions, right?
Yeah.
Yeah, I can put in the chat.
Sure.
Lulu beat me to it. There we go. Yeah, it's the webinars link on the website. Yeah.
Cool.
Yeah.
Okay,
yeah.
great.
I should post it there within like the next day or so. Yeah.
Awesome.
And then an email will be sent out, letting you all know that's live.
Great. Thank you so much.
Mm-hmm.
Of course.
Yeah.
Yeah, thanks. Have a good one.